So my name is Bhavik Merchant. I'm a senior program manager on the Power BI service team, and literally my focus is performance. So a tiny bit of history. I'm an African Indian who spent the last 14 years in Australia and then moved to Redmond about a year ago to join the product team. Been with Microsoft about 4 years, but before that, I've been a practice manager, a BI consultant, been hands-on across the entire data stack, and I used to be a cloud solution architect at Microsoft before this role. So I helped a lot of large organizations move their entire data estates or plan new projects in Azure. So Power BI was a big part of that, but also a bunch of the other stuff that we use in the Azure Data Platform. So the objectives for today, we really want to identify areas where your choices can affect performance. So the thing with Power BI is it's pretty flexible, and sometimes this kind of works against you. So we want to kind of go layer by layer within the product, and we want to identify where these issues can come about and look at common pitfalls, and then I'm going to give you some suggestions on how to work around these problems and how to design for scale and for high performance. We're going to recommend how to mitigate these issues, as I said. We're going to jump into the new performance analyzer to see how we can actually identify types of problems where things are slowing down. So if you haven't seen that, that'll be a good opportunity to take a look at the new kind of feature we released last month. And I'm going to wrap up with a few guidelines for performance management. You know, performance isn't something you should just think about like once or twice. It should be built into your entire process. So I just want to cover what this session is not about. You know, I generally deliver like 2 full days of performance training to our partners and so on. So we're not going to be able to cover everything. But what I have done is I've included sections and slides for bits that I'm not going to cover. So I'm not going to cover DAX specifically today, but there's a whole section on DAX which is hidden. When you download the slides, you'll have access to all that material. So there's tons more. Even in each section, I've got some hidden slides because there won't be enough time. So please do download the deck. You're going to get a lot more tips than I'm going to be able to cover this morning. So why performance management? Well, I think it's obvious things should perform quickly, right, or as fast as possible. But really, I'm sure those of you who develop and maintain solutions have found that users complain quite quickly when things are not performing so well. And the higher up the chain you go, the more trouble that causes. You know, once you reach C-level execs, people want their numbers straight away. But they are related benefits, and they're all listed there. You know, most often when you build stuff that performs well, you're optimizing many areas of the product. So effectively, you are using less resources or using resources more, more optimally. So performance, you know, has a double benefit. It can lower costs in a short to medium term too. And the other big one is you get a deeper understanding of the system behavior and system design. By forcing yourself to think about performance, often you have to understand what the system is doing under the covers so that you can actually design to take advantage of the way the system behaves. So we'll get into some of those details shortly. So as part of my work in engineering, myself and a bunch of consultants talk to some of our biggest customers who are having performance problems. And over the last kind of 6 months to 8 months, what we've learned is that the vast majority of performance issues in Power BI are due to certain choices that are made. And often we get the call when it's way too late. They've scaled their solution to many billions of rows, thousands of users. They've already deployed everything, and suddenly it's slow, and now they pick up the phone and ask for help. And it usually takes us a few weeks of investigation to realize, look, you could have made these choices a bit differently, and in most cases, you could solve this problem yourself. And you know, part of it is lack of education, and that's kind of part of my job to spread this knowledge and to help you build models and reports, et cetera, that perform very well. And what we found is, you know, enterprise solutions often exhibit multiple classes of problems. So, you know, pretty much every area I'm going to cover today, there's something they could have done differently there to actually make their things run faster. So where can we affect performance? Well, we can affect performance in a lot of areas, and I'm going to cover, you know, some of these today. Reports, dashboards, you know, data models, calculations. You've got, you know, use of storage modes, direct query versus import, and now we've got composite models to think about. Data loading. I hope to get time to cover some data loading, but if not, I have a whole section on optimizing Power Query too. This doesn't so much affect your report performance, but it can affect your refresh performance. And if you have a premium capacity, resources are scarce or dedicated, and you know, you're not going to automatically scale. So you need to, you know, think about what your refresh is going to be doing to your capacity while reports are also running at the same time. A couple of other ones, I'm not going to talk about them specifically. We'll get to those shortly. So what is special about premium? Well, everything I had on the previous slide applies to premium, plus more. So you need to optimize every layer, but because premium capacity is dedicated, you need to worry about overall resource usage too. Not just, are my reports designed well? Are my models well? Are my, designed well? Are my calculations fast? You might have the best models, the best people writing your content for you, building your models for you, but you could still get terrible performance on premium if you don't manage the capacity properly. And unfortunately, I don't have a lot of time to cover premium today, but I have some references for some of my colleagues' sessions that are doing a deep dive on specifically premium behavior. And I see Josh sitting in front here, so if you have premium questions, yeah, feel free to come and ask us. We're both working with premium a fair bit, but Josh a little more than me. Okay, so I've got some links there. Some have already happened, but you can always go and get that content from the download center. Okay, so let's jump into architecture and configuration. So the way I'm going to do these sections is we're going to cover the high-level goals in each section, and then I'm going to cover individual tips, common pitfalls where you can actually make different decisions and improve your performance. So really, architecture and configuration, we're thinking about the final deployment. Usually we hear, hey, everything works great on desktop, and then I deployed it to the service and things started happening, weird things started happening, things slowed down. And it's usually because the whole architecture and configuration is totally different. You may be using gateways once you publish. You may be in a completely different data center. There's lots of different things that can affect your performance once you publish. So really, the few of our goals here are, we want to choose the right storage mode up front, DQ versus import versus composite models. You want to reduce network latency, improve throughput, and you want to use resources as efficiently as possible. And then premium sizing is also a big thing here. So let's take a look at a quick diagram. This is just a general diagram. It's not how every single Power BI solution would look, but if you kind of added most of the components, you'd get certain paths from sourcing data to deploying it into the service that you see up there. And I'm going to keep referring back to this diagram and zoom in on certain areas as we go throughout the presentation and show you where we're going to focus. So where is the time spent? Well, one area that affects you with architecture and configuration is really the data sources and how they're connected. So the next few slides are going to talk about kind of those three red boxes right there. So let's talk about storage mode. This is the basic thing that you should actually think about right up front. Am I going to use direct query? Am I going to be using import mode? Or do I potentially need to use composite models in a mixture of both? Now, if you can, you should always choose import mode. It's going to be in memory, it uses our proprietary compression technology, and you're going to get great speed, and you're not going to have any limits with DAX functions, right? Even with direct query, you can achieve everything you want to, but certain things will be a bit more difficult to achieve. Like time intelligence, for example, is not as easy to do with direct query. So just know that up front and kind of understand what the limitations are in the storage mode that you pick. But sometimes you can't use import mode, right? You might have extremely large data volumes, hundreds of millions or billions of rows, that the Power BI model itself, even if you optimize it, might be 35 gigabytes. It's not going to fit on Power BI or Premium at the moment. So you might have to consider Azure Analysis Services or Analysis Services on premises for that. And Marco is going to be doing a session at 1 o'clock in this same room. You may have signed up for that session too. It's going to be awesome. It's complementary to my session. And he's going to deep dive into Vertipack Analyzer and how to understand compression. So that's something you want to think about upfront, right? How compressible is your data? How big is that model going to end up being? But sometimes you might need near real-time access to your data. And that's where direct query is great, because every time you run a report, every time you filter or slice, you're going to issue queries to the backend, and you're going to get the latest data back. And that also helps with high volumes, because you're going to keep it in that backend system, be it SQL Server, be it a Hadoop cluster, or whatever it is. Often large enterprises have lots of investment in traditional data warehouses and OLAP systems, right? So if that's the case, you probably don't want to pull it out of that nice semantically modeled layer and then remodel it in Power BI. It's a double hop, you're duplicating effort, and it's probably not required. So in that case, you're going to be using Live Connect, and you're not going to be using either of our storage modes. And sometimes it's regulations or compliance. You are not allowed to put your data up in the cloud for, because your industry says so, or your company guidelines say so. So storage mode considerations. On average, we get between 5 and 15 times compression, and I'll tell you shortly how you get better compression. Think about if Premium or Analysis Service is an option. So as I said, if you think you're going to have very large volumes of data, you might need to consider Premium, because Premium currently can host up to 10 gig data models. We're working on increasing that. And analysis services, the S9 SKU in Azure can go up to 400 gigs. So you can get really, really large models in analysis services. And if you have even bigger requirements than that for whatever reason, you might need to consider, analysis services on premises. Even running in a virtual machine in Azure, for example, you might get the biggest machine you can possibly get in Azure and stick analysis services on there if you really have to. But think about if a blended architecture can suffice. Now that we have composite models, it's possible to mix and match import and direct query. So you could load some of the smaller tables into import mode to increase speed and leave some of the larger tables in direct query mode, and that will give you a nice blend. And also aggregations will be very useful here. I already mentioned limits in direct query mode. So let's now look at network latency. So network latency can affect you everywhere. Everywhere where there's connectivity between a client and a server or between components like a gateway and the cloud, you can slow down. So how do we actually improve this? Well, I'm going to go through a number of scenarios now, and let's see how we could potentially fix these problems. So suppose you have components in your data pipeline, and they're spread around all over the place. And we sometimes see this as an obvious thing customers can fix. So, you have your data sources sitting on premises, you have other stuff, your Power BI deployment obviously sitting in the cloud, or you have a geographically distributed office, and you're pulling stuff from as far away as possible, whereas you could have different options there. So just think about putting the services as close to each other as possible. And I'm going to give you a tip about gateway placement when I get to the gateway section. So why is it undesired? Well, the further away you put components, it's just simple physics, right? The stuff has to travel across the wire, and the further it travels, the slower it takes. But across networks, it's not just the speed of light going across the network. The more hops you have in between, the more routers and those kind of things come in between, they have to do some kind of processing, and it adds a slight delay. And when you're putting stuff up and down the wire, it can slow things down. So what could we do? Well, try to co-locate all the services as much as possible. Even if you have stuff on premises, try and put it on the same network so that they can talk to each other quickly. An easy option is to just have a cloud replica. So if you have on-premises data and you're using a gateway and you're finding you just cannot get the performance to where you need it to be, consider replicating that data source into the cloud. There are many, many tools to do these kind of things. Obviously, SQL Server and those kind of things can do it. But even third-party tools, third-party databases, Oracle, et cetera, they all have these replication technologies. Obviously, it comes at a cost. There may be a license cost, and there's a cost of running stuff in the cloud. But if you want that kind of performance, you might have to take that hit and just pay up. Often in development mode, we find that if you have cloud data sources, now the developers are struggling because they're trying to do Power Queries and they're pulling data down all the time. So if you're using Azure, consider just having development virtual machines in the same region that your Power BI deployment is in, so that the VMs are talking to the Power BI services and pulling data right in the same data center, which will be much, much faster than pulling it all the way down the internet to your on-premises environment. If you're using analysis services, make sure you put the analysis services in the same region as your Power BI deployment. If you're not sure, you can go help about, and once you're in PowerBI.com, and it will tell you which region you're in. We've sometimes seen customers have an analysis services instance far away from their Power BI deployment, which doesn't help. And the last one is Azure Express Route. If you must have things on premises, that's fine, it's fully supported, but try to optimize that connectivity. Use Azure Express Route, which is a dedicated fiber connection with low latency and potentially high bandwidth, depending on how much money you want to pay for that throughput. Okay, so the gateway. Everyone knows the gateway, I'm sure. When you want to connect to on-premises data sources, you need to stick a gateway there, because the gateway is actually your gateway to the cloud. An important thing to note, though, is that the gateway isn't just a dumb machine, a dumb service that sits there and passes data through. The gateway does a lot of work, which explains why our minimum recommended specs are quite high. The gateway actually has the mashup engine on it. It does compression, it does transformation, and it sends only the final transformed data across the wire. And that makes sense, right? You don't want to send uncompressed data all the way to the cloud and process it there. So the gateway does a lot of work, and you need to make sure it's optimized and that it is close to the data source. So we've sometimes seen people put gateways in Azure because it's nice to manage VMs up in the cloud, right? It's very easy to scale them up and down. But if your data source is sitting on premises far away from the cloud, you are sending uncompressed data to the gateway and then doing all the work in the cloud, which is not required. So put the gateway near the data source. So you should monitor and scale your gateways. We have a bunch of documentation on how you can monitor and what sort of performance counters you can use. And the Gateway team, I spoke to them last week, and they're doing a lot around performance management now, because they realize that customers need more data, and without the information, you can't actually make the right decisions on how your gateway is performing. So the Gateway itself has a number of limits. They're going to be published online soon. That's a kind of gap we have in the documentation, so we admit that that's kind of missing. It's coming soon. But really, you don't want the Gateway becoming your bottleneck. And on the next slide, I'm going to have some links to some performance counters that were added recently in the May release. So you don't want queuing and resource contention to happen at the Gateway. You might have a gigantic SQL Server box on premises that's doing direct query and able to handle all kinds of queries. But you could be throttled at the Gateway because you have thousands of users hitting just one gateway. So you want to scale up or scale out the gateways. If you want to handle bigger transforms, you might want a bigger gateway. But if you want to handle lots of users at the same time, you might want to have many gateways so you can actually distribute among them. Now, at the moment, we don't distribute in a very clever fashion. We kind of randomly pick gateways, but that's going to be improved in the near future to actually have a more load-based distribution system on the gateways. So the minimum size is actually important. As I said, the Gateway does a bunch of work, so you want to make sure you size that appropriately. A good tip is to separate direct query and scheduled refresh data sources on gateways. The reason being, the Gateway has a limited number of resources, and it has a cap on the total number of connections it can actually handle and the total number of activities it can handle at one time. It's 500 at the moment. So if you have a lot of usage, like people are using reports and there's direct query data going back, and suddenly you have 5 or 6 refreshes that all start at the same time, your Gateway is now doing a lot of work. It's crunching all the data, it's sending it to the cloud. At the same time, random direct queries are coming in, and it's getting very, very busy. So it's a good idea to separate these so you can scale them appropriately for the load. And you might even do things like, even if you're running a virtual machine on premises, you might have the direct query gateway turn on only when you need it to turn on, when your refreshes are scheduled. Or you could scale it down when you don't need that much power, just to improve your overall usage. So there are quite a few things you can do here. So here's some links around the Gateway performance monitoring. The top one is kind of a link to the new documentation around all the counters you can get. The cool thing is the Gateways team have built a Power BI template file, and they updated it kind of yesterday, I think, with their June release. So with the Gateways, you may not know, but you can turn on diagnostic logging. So if you turn these things on and you use some of these new counters, you can actually capture those traces and load them straight into a Power BI template and analyze that data straight out of the box. So that's a really cool thing that they've done. So please go check that out. And the final thing around architecture and configuration is query caching. So this is a feature I was involved in. It's for premium only, and we've seen really, really, really fantastic results with some of the slowest reports. So we measure report times in percentiles, and everything from this kind of 75th to the 99th percentile, we've had up to 100% improvement in speed, like double the speed that it used to be before. And this is almost a free thing. You can just turn it on. It doesn't really affect your premium memory usage and so on, and it's effectively just a nice performance tweak. And we plan to add more features to this particular setting. Can't say what yet. We're still planning it, but this is just the beginning. Okay, so any questions? I do have swag, by the way. I have awesome Power BI stickers, and I have Power BI pens. If you come back later, I'll also hand them out. So I probably won't throw them at you, so maybe come up. The room's big. I don't want to hit anybody in the head. All right, so data modeling. Where is time spent? So I've put the box just on the analysis services, the internal piece there, because as we know, Power BI is analysis services under the covers. But really, even if you were using external analysis services, the data modeling is still very important. It's the same technology behind the scenes. So at a high level, and I've seen this very often, an inefficient model can completely kill a report. I had a customer who rang me who had a 150 megabyte model with 6 tables in it, maximum 200,000 rows in any table. And their report was taking 3 minutes to load for all the visuals to finish drawing. And we had all this conversation until eventually I said, look, can I just have a look at your model? And in about 30 minutes, I gave them about 7 tips. And they emailed me 2 weeks later to say, oh, my word, amazing. So, it's not that obvious what you could do in a model. but hopefully I can show you some of the things you can do to really get the best performance. So some of the things we're aiming for here are to get the model as small as possible. Why? Well, you use up less memory, and we don't keep models in memory all the time, at least in Power BI. In analysis services, it's different. But in Power BI, we don't keep models in memory all the time. When they are unused, they get loaded, well, I get unloaded from memory, and then when they're needed again, they get loaded from disk or blob storage back into memory. So the smaller your model is, the faster that initial load is going to be. So that's going to be good. The other thing is the schema should support the analysis. And by schema, I mean your design of your tables, what attributes you put in them, and the relationships that you design. Often we see people just importing everything they can because, hey, you never know, somebody might need it. So full tables, all the columns, without any changes. That might work, but in cases where you're going to start scaling your model to very, very high data volumes or lots of usage, this could actually hurt you. Because again, you're just putting stuff in there that you don't need. Your refresh times will increase because you're now compressing columns that you never need. So just think about this. Relationships are really important. Relationships should be built thoughtfully and purposefully. Don't just relate tables because it seems to make sense. Relate tables that you know need to be related because you need filters and those sort of operations to work. So the biggest thing you can do is aim for star schemas. Has anyone not heard of star schemas? I expect most people have here. You can put your hands up, it's fine. A couple? Okay. So this is going to be kind of basic stuff for most people. Dimensional modeling is a whole technique, a whole discipline by itself. There's many thick books on it. I've got a couple of links here. But really, it's designed to, the technique structures data for analysis. So, the way we think about data when we analyze it is very different to the way we store data in database systems. There are lots and lots of tables that's optimized for reading and writing small pieces of data, whereas when we look at analytical data, we're often aggregating and we're grouping. So what we end up doing is grouping into facts and dimensions, and I have a picture coming up. Usually it requires denormalizing. So denormalizing means, say you have a org structure entity. In the original source system, it might be split over 6 or 7 tables. What you normally do in dimensional modeling is denormalize that and bring all those attributes together into a single entity so that a business user goes, hey, I'm looking for org hierarchy stuff. I expect to find it in one place, not split it into multiple places. And this is really important when you consider the self-service aspect of Power BI. You want people to have as few tables and as less cognitive overhead as possible. You don't want them searching around with hundreds of fields and hundreds of tables, figuring out which fields they need to get their report built. So that's what a star schema looks like. I won't go through this whole thing, but I've got a link to Kimball Group's 4-step process. And the cool thing about this is, even though it can be quite technical, you can teach business users using those 4 steps, right? Think about your business process. What are the numbers I want to break down? Then think about how you want to, what are the numbers I want to look at? What are the metrics I want to look at? And then how do I want to break those down? By which dimensions? Is it by geography, by people, by dates, et cetera, et cetera? So it's quite a nice and simple technique, but it's really powerful. So I've already talked about removing tables and columns. The scenario here is you've got lots of tables and columns there that are not used. I've already talked about it. Increases model size, increases time to load to memory, increases refresh time, but it may also affect usability. Having a lot of stuff in the model that nobody needs is just making it more difficult for your business users. Okay, another way to improve your performance and decrease the size of the model is to avoid high precision or high cardinality columns. So high cardinality just means very, very unique, right? The more unique values you have, the higher your cardinality is. You want to avoid high cardinality columns. And in extreme cases where you're really trying to squeeze every piece of performance out, I've even seen people use clever techniques like taking high cardinality things which are very big, like GUIDs, like Dynamics loves GUIDs if you've ever pulled stuff out of Dynamics. People have mapped those GUIDs and hashed them to their own unique keys so that they're much smaller and that data type is a lot smaller and it compresses better. So consider that your model might have very high precision numbers and dates. Like, do you really need a date timestamp to the milliseconds for normal analysis? If you cut that out during your Power Query process and have the date only, with just 12 a.m. default, that will actually be compressed more because it's a smaller number. Power BI stores dates as numbers internally, so it's going to be compressed more. Highly unique, I also talked about. It's all about compression. The more uniqueness you have, the less compression you can get because compression, the whole discipline of compression is taking advantage of repetitions in the data to actually squeeze things down. So you want to remove columns that you don't need. You want to reduce precision where you've got super high precision. And the big one is to split date time into dates and times. So if you have lots of dates and times and you do need to analyze by time, take your date times and split it into just the date portion and just the time portion and link those to separate date and time dimensions. It's going to be a lot smaller. You're going to have a lot smaller date time tables. Another one is to use integers instead of strings, and I mean text here. Where possible, try to make things numbers. Sometimes a source system will have things typed incorrectly, right? It might only be storing numbers, but it's typed as a text, especially older systems where have everything as text. You want to go in your Power Query and make sure you set that data type to an integer, if it is an integer, which will be much more compressible than text. Now, if you are using integer keys, it helps to pre-sort them. So you can pre-sort the data before it gets compressed into Power BI. This just takes advantage of one of the techniques that Power BI uses to compress. It uses run length encoding. And effectively, what Power BI does, it compresses in segments of millions of rows. Now, depending on whether you're in Power BI analysis services, it's either 1 million or 8 million rows at a time. So think about it. If you're already sorted, and I'm using run length encoding, which takes advantage of the range that you have, in each segment, if it's already sorted, I have the smallest range of values in each segment, so I can compress that more. So it's a simple thing you can do, and this tip has been around since Power Pivot days, since before it was even called Power BI. Next one, be careful with bidirectional relationships. The problem that this customer had that I talked about with the tiny model that was super slow, they had the largest tables in their model all connected to each other using bidirectional relationships. So when the filters were being applied, those filters were being propagated all around the model across very big tables. Well, not very big tables, 200K rows, which is tiny. But that was really, really slowing things down. And it was not required for the analysis. So I advised them to just make them all single direction and only turn on bidirectional when the business scenario needed it to filter that way. And that helped a lot. Now, if you are using pure DQ and things are slow, just remember that we now have composite models. So with composite models, you could actually mix and match. And a great idea, if you don't want to move everything into aggregates and things like that yet, is you could just put your dimensions into import mode. Dimensions often don't change that often. So, you could have that in import and have it cached, but still have the facts and your actual data coming from the direct query. And this will especially speed up slices, especially if you have a lot of slices on your report, because that will hit the in-memory cache, slices will populate quickly, and then, when you need to populate your grids and your tables and your charts, that will go to the DQ source. So at least the initial load experience is going to be a bit better there. Dual mode? Oh, sorry, dual mode. Yeah, you're going to need to set them to dual mode, my mistake. So dual mode will allow Power BI to pick whether it uses import or direct query based on the query that you've actually sent to the engine. Thank you, Josh. I'll fix that. Okay, so let's move on to dashboard optimization. So where is the time spent now? Well, now it's on the visual layer in Power BI, in the dashboards and the reports. So at a high level, dashboards in Power BI were designed to provide a very quick access to summary data. And this is a good design principle in business intelligence anyway, right? Have the important metrics at a summary level surfaced, highlight the things that need attention, and then provide some kind of click-through or drill-through into additional information. So Power BI dashboards were designed to support this kind of analysis. But some configurations can actually slow you down. So what we want to do with dashboard optimization is to try and use our tile cache wherever possible. Power BI actually caches dashboard tiles behind the scenes for you, so that when you do go in there and hit them, you get those results very quickly. And I've already talked about the Launchpad design principle. So let's dive into it a little bit more. If you have a dashboard with so many visuals on it, the question really is, do you need all those visuals on one page? I've seen dashboards that scroll for like 6 or 7 pages with every single metric there. Just think about redesigning that potentially, Even with the tile caching that we have, what can happen is we try to refresh those tile caches behind the scenes. So with an import model, you can't control the tile refresh schedule, but what happens is, by default, when we finish refreshing an import model, any dashboards that use tiles from that report will have those tiles cached. So suppose you had 100 dashboards and they had, 50 unique tiles each. And they're all coming from the same import model. After your data refresh completes, we automatically kick off all those tile refresh queries. because now we have fresh data, we need to update all of that so that users don't get stale data. So we've seen systems kind of overload, especially on premium. You can actually overload the system because you've finished refreshing and now you have thousands of queries coming into the system trying to refresh these caches. And it's made even worse if you have row-level security, because individual users have unique security contexts. So we cannot assume that user A and user B have exactly the same data. So if the user has hit that dashboard before, we will then go and cache the queries in that user's contexts. So it could make it even worse. You could have even more queries. So the other thing to do is to avoid single visual report tiles. So you know how in Power BI you can pin individual tiles from a report, right? But you can also pin the whole report. So what we've seen in some cases is people have built a report which is just one visual. Maybe it's a big grid or something like that, or a chart, it doesn't really matter. And instead of pinning the visual, they've pinned the whole report. Now, these are called live tiles, and they are not cached. So if you pin a whole report to a dashboard, it's not going to be cached. So people are going to get this experience where the actual dashboard tiles come very quickly, and then the report, which looks like a tile, but it's actually a pinned report, is going to be slow. So just be aware, if this unique situation happens, just pin the tile and not the report. Quite simple. But the other thing can also happen where you have pinned a whole report because you want to do that, but it's very busy. There's a ton of content on there, and it's mixed with other dashboard content. Again, it's a similar idea here. Your usability could kind of be affected because there's lots of stuff on one page, including all the dashboard tiles. But at the same time, it's going to be an inconsistent experience because the dashboard tiles load quickly, but that live report kind of might come up in pieces. And then people complain. They don't like that experience. But hopefully, some of the report tips I'm going to give you are going to help with that anyway. So I talked about that cache refresh. This is where the setting is. It's in your dataset settings. It's called scheduled cache refresh. You can go in there and you can change that timing if you want to. So you can actually avoid doing that refresh as often as we do. So for direct query in this example, the default is 1 hour. And you might want to drop that down to less frequently just to spread out load on your system. Okay, so we're done with dashboards. Let's jump into reports. Now, this becomes interesting. With reports, you could actually put load on your client machines, the actual computer running the web browser to access your reports. You could put load on the analysis services too. So either hosting Power BI or, hosted in Power BI or hosted externally. And we'll explain why. So at a high level, every visual that is data-driven generates a query. So the more visuals you put on a page, the more queries you are sending to the analysis services engine under the covers. Queries are sent in parallel batches, so we send a whole bunch. We don't necessarily execute them all at once, and we don't necessarily collect all the results at once. There's a bit of complexity behind the scenes. But at the end of the day, you are sending pretty much one query per visual. So if you have a lot of visuals on a page, lots of slices with lots of values and lots of visuals, you are actually sending many, many queries and sometimes returning a lot of data. So you want to try to think about this and really optimize how many visuals you have on the page, especially the complexity of the visuals. Where it's not possible to reduce the number of visuals, there are other techniques I'm going to give you today. So limiting the number of visuals on a page. Our official documentation says something like 10. I think that's way too low. Who would be happy with 10 visuals on a page? Like as a maximum? Nobody, right? Josh would. Of course you would. But so my guidance, and especially with the work I've done with customers, is around 20 maybe, and it's about. This is not a hard limit. I want to be very clear. This is not a hard limit. It's a suggestion. Just think about when you start reaching 10, 20, 30. Just think about the number of visuals and the complexity of the queries being generated by each of those visuals. Now, it could overwhelm the source system. Think about direct query. This is especially useful. It's especially a problem for direct query. Often direct query systems are not optimized for aggregate queries. So if you're having all these queries hitting your data source at the same time, it might be a lot slower than it would be if it was an import model. So what you want to do is try to set some default context to limit how much data is going to come back. If you're going to have to run all these queries, if you need all those visuals, try to limit how much data is coming back. So you could use default slicer selections. So often we see people build reports which are really, really busy with lots of thousands of values inside the slices, but they don't choose a default value. So if you just set a default value on each of the slices, and maybe even the one that's going to have the highest filtering effect on the data, you're suddenly going to issue queries which are filtered quite well, which return less data, and it'll come back faster, and the experience is going to be better. And then users can go in and change their selections if they want to. Another good idea here is to just use drill through, right? We can drill through inside a report, we can drill through across other reports. So think about that same Launchpad design principle. Do I need 6 detailed grids on one page, which have, thousands of rows and 50 or 60 columns with hundreds of measures on them? I've seen this. I've seen, 30, 40 measures. Inside Microsoft, actually, some teams have done this. And, it might work just fine when you test out a few rows, but once you add, all the data in there, and once you have hundreds of users hitting that at the same time, things start to slow down a lot. So think about that principle. Highlight the numbers you want to, and drill through to the detail. Another interesting tip we have, which is not in the deck actually, is to use our tooltips. So if you have additional details that are only needed infrequently, just put them in a tooltip so somebody can hover over, and then the details pop up. And then you're issuing a tiny query for one row of data, not for every single row of data in your grid. The other big one that you can do is to combine individual visuals where you can. So often people use our card visuals and stick them across the top of a dashboard, right? High-level KPIs. They have 6 of them. Well, 6 visuals is 6 queries. You could use a multi-row card or just put multiple visuals in the card, and maybe the design's going to be a little bit different, but you will get away with reducing it from 6 queries to maybe 1 query, and they'll all be sent at once. And so less visuals to draw and less queries for the engine to process, which is going to be great. Okay, the other thing you want to do is you want to review your visual interactions. By default, Power BI has everything interacting with everything else. When I click a slicer, when I cross-highlight, everything else cross-filters. And that's cool. In most cases, that's what you want. But sometimes you are going to be filtering things on a very complex report that you don't need. So what you should do is you should go in your view, you should go to Edit Interactions, and you should simply disable the interactions that you don't need, especially between slices that don't need to filter each other. So sometimes you might have like a 3 or 4 level hierarchy, and you have 3 or 4 slices, and you want the top level to filter the second level, etc. That's fine. But do you need those hierarchical slices to filter other slices? Do you need them to filter the date slicer, your geography slicer, etc.? If that's not needed, turn on that mode and disable the interactions where they're not needed. So that means when people interact, you are sending less queries to the engine because you're updating less components on the page. And again, that's going to improve your interactivity and improve your resource usage too. And my screenshot shows you the setting. So once you turn on that mode, you'll get little icons that will come up on each visual. And then the box I have there is showing where you've canceled the interaction between the slicer on the left and the slicer on the right. Okay, the other thing you can do is you can use filters to limit visuals. If you must have busy visuals, like grids especially with thousands and thousands of rows, well, could you just do a top N? Do people literally need to see thousands of rows on a report? Sometimes you can give them a default view, use a top N, and then allow them to use other filters to get to the data they want. Or again, drill through into detail. Okay, so slices with a very large number of values. Again, sometimes people use slices with thousands of values, And that might be okay, and it's nice to have a slicer on a page because it's obvious that somebody can click on it to filter the report, because our filters are kind of hidden on the right. Depending on the state the report is saved in, you might not even see them. So my recommendation is to think about the usage pattern of the slicer. Slicers are really designed to provide ad hoc analytics, right? I see my default state, I want to look at different slices of the data. But if you want to set something just once or twice, set a context, like, hey, I want to look at financial year 19, and now I'm going to play with other stuff. Why don't you move that into a filter, right? Especially when you have thousands of values. We've seen many cases where it's just, they need all these values because they're a large organization. People set that context once, and then they don't touch those slices again. So move those to the filter pane. The other advantage you're going to get is the filter pane will only execute the queries to populate the fields when you open up the filter pane. So the initial view of the report is not going to run all those queries to populate those slices, because they're not slices anymore. They're hidden away filters. So think of it as a parameter that's applied in the background. And then when you open up the filter pane, then we go and run the query and we say, hey, these are the values. So again, that's just a small tip that's going to potentially give you some good gains. I already talked about slicer selection defaults, so I won't cover that again. So let's jump into a quick demo. I think I'm doing good for time, 20 minutes left. So any questions before we do a bit of a demo? Sorry, could you speak up a bit? Yeah, so the question is, if you had multiple integer fields, which one would you sort on? And would you sort in Power Query? So good question, thank you. If you have multiple fields, I would sort the keys first and then sort on the other fields. Now, sorting is a double-edged sword. You can do it in Power Query, but if you're sorting very large data sets, it's not advised to do it in Power Query. You want to use pushdown where possible. And if I have time, I will get to that section and give you some Power Query tips. So hopefully that answers the question. Sort the keys first and then other fields. And they will still be sorted within those ranges. So you'll still get some advantage there. Okay, so let's jump into a demo. We're going to find some bottlenecks with the new performance analyzer. So I have a couple of models here. No thanks. Can I quit that? Oh, come on. You want me to sign in? Okay. What's that? Oh, now I can. Okay, good. All right, great. So let's maximize that properly. Okay, so I'm using a kind of development build with the new look and feel that you've all seen now. Who likes it? A few? Okay, I like it. We've been using it for about a month, and I quite like it. Okay, so you notice I've opened up this report, and I've started on a blank page. And Marco's going to go into this in a lot of detail later at 1 o'clock. But really, what we're trying to do here is avoid any caching that's done by Power BI Desktop. Power BI Desktop does cache things, and we'll see that effect soon. So if you're doing some performance tuning, start on a blank page and then do your analysis, because you're going to be hitting a cold cache, and it's going to be the worst possible performance. And you want to optimize for the worst case, because then the best cases will be even better. Okay, so you're going to your view here, and you'll notice I had to restart my computer, so my friend zoom it. Okay, so performance analyzer is here. Turn it on, you'll get a new pane. And there it is. And you'll notice you've got a few controls here. What I'm going to do is I'm going to start recording, and then I'm going to flick over to my report page. Now, this is a made-up report. It's just got tons of visuals on it, which are all duplicated, but it just illustrates the point. So I'm going to click on my tab here, and this is going to take a little while. I've just duplicated the same visuals again and again and again. You can see lots of spinnies, lots of stuff happening. Slowly, they start appearing. Okay, so this performance is not great. It's not terrible, but it's not ideal. So what we can do in the performance analyzer, and this just got released in the June release. So if you haven't seen it, you can now sort. So I can sort this by total time, by action order, by DAX query time, or by the visual display time. So, what am I trying to optimize for? For slow visuals, potentially, or for slow DAX? And you could do both, of course. What we also have now is support for direct queries. So if you have a DQ model, this will tell you which direct queries, the exact query that is being sent to the backend, which is really useful because it's tough to optimize direct query sources in large organizations where you don't control that source. The admins are probably going to be like, hey, we're going to have to run traces, and we don't want to run that in production, and it's going to be a big deal, and we need a change window, and all that kind of stuff. Well, great. You can just give those database people the queries, saying, hey, these are the queries my report is sending. Can you help me optimize for these? So that's good. Okay, so I'm just going to expand a couple of these, and we can see that the breakdown gives me the DAX query time, the visual display time, and other. This other thing is quite contentious, and what it means is the thread. So when you do multi-threaded programming, you have multiple threads, so things can happen in parallel. Because Power BI is literally just a browser, like in Power BI Desktop, we're just running a browser internally. We're subject to the limitations that browsers have. And Power BI on the visual side is all JavaScript. So JavaScript needs to be executed, and it's single-threaded. So what's happening here is you have a single thread bouncing around all those visuals, starting them, and then doing some other work, and then potentially coming back and finishing the work. So the actual time taken for the DAX query and the visual display were 46 milliseconds. But when that spinny finished, when all the work was actually completed, it actually took, in this case, about 6 seconds. So just be aware, you can't really control that other time very easily. Well, not directly, but indirectly you can by reducing the visual complexity and the number of visuals. Okay, so in this case, what you might want to do now is you sort, You work out which the slowest visual is, and then you decide if you need to optimize the DAX or the visual. You know, is the visual drawing time significant? And I'll show you another one shortly. Or is the DAX time significant? Now, I talked about Power BI itself doing caching, right? So I'm going to clear this. I'm going to go to my blank page here, and I'm going to come back to the many visuals page again. And it's going to do its drawing. It'll be a little quicker this time, but it's not going to be great. And I just want to demonstrate how, by flicking pages across and coming back, you'll notice now there's blank for the DAX query time, because Power BI has used its cache. It knows nothing's changed, and it's not going to reissue those queries. And that proves that it's the number of visuals that is slowing this down, right? We haven't issued any DAX queries at all. Okay, now I want to show you another one. Let me stop and close that. Okay, so this time, same thing. I have a blank starter page. I'm going to turn on my performance analyzer. I'm going to move to, so you saw that was pretty quick. This is an AdventureWorks model that I've tweaked a little bit, so I'm just going to quickly show you the data model. It's a very simple model. I have order header, order details, a few dimensions. This is not a very big model. Okay, and if we look at the order detail table, it is tiny, 121,000 rows. Okay. Now I'm going to go back to my report, and actually, I'm going to start recording here and just refresh visuals here. I was supposed to do that. So I have two tables, and you can see one DAX query took 15 milliseconds, the other one took 8 milliseconds. Okay, great, quite quick. And you'll notice I have two measures here, one called unique black products fast and one called unique black products slow. So I've done a distinct count measure to try to calculate the number of products at whatever granularity is in the table that were black. You know, how many unique black products were sold? For whatever reason, that's what these guys want to do. Now I'm going to switch to the second page. So let's clear this one, and let's jump into unique by account number. And this is going to take anywhere between 1 and 2 minutes to load. Any questions while we wait? Okay, so I'll explain what I've done here. My slow measure has been written really badly. I've purposely not taken advantage of the internal relationships in the model and done something silly. And I'll show you the DAX measures in a second. In fact, I'll show you now. So, where's my unique black products? Well, I can just search for it here. Okay, so I've got my fast version. And that's a very, very simple measure. I calculate distinct count of a product ID using product color equals black as the filter in the calculate, right? Very, very simple. Yay, it's done. Okay. Just look at the times here. 46 seconds versus 158 milliseconds. Same result, right? 79, 79, same numbers. Let's look at my slow measure. I've done something silly here. I'm still doing the calculate of the distinct count, but what I'm doing is I'm using a filter, right? And I'm going across and reaching out into related. So I'm taking a filter, which is a row-by-row operation. I'm expanding the context by using the related. And literally for every row of the output table, I am scanning the entire fact table. So I'm not taking advantage of calculate and its ability to understand relationships here. Bad way of writing the DAX, but I wanted to do this just to show you how things can slow down really, really badly in a very simple report. So let's look at the table. And you can see 46 seconds in the DAX query, the visual display was 54 milliseconds. You can't even blink that fast. So two extreme examples, one with too many visuals where the DAX queries were not affecting the performance, and the other one, a tiny, tiny visual where the DAX queries are affecting the performance. The last thing I want to do here is just clear and just quickly show you a report sample. So this is a more realistic report. Something's broken, doesn't matter. But what I wanted to focus on was this custom visual here. So what I'm going to do here is just quickly sort by by visual display time. And I want to sort descending. And you'll see that the filter, and the good thing about this performance analyzer is when you click on the entry, it will highlight that visual, right? You see it selects that visual. So I know it's this visual here. And you can see that the visual display time is 1.2 seconds here. Now this is an older custom visual. I haven't updated, but It's just illustrating how certain visuals might spend a lot of time drawing because they have to do something complex. So again, you might want to change your design. If this one was really slowing you down, you might want to change and not use this time slicer and use more typical slicers instead. Okay, so that's demos done. Let's jump back to our slides. Okay, I'm going to skip data loading and refresh for now. And let's move on to, data flows 2. There's a whole DAX section I talked about. Again, please do download. But let's wrap up with the performance management framework, and then I'll leave space for some questions. So where do you focus when you're doing performance management? Well, you need to really consider every layer of Power BI. I haven't covered every single one, but DAX is important, and other areas are important too. Review the architecture first. That's my suggestion. If you haven't already deployed Power BI solution, just take a step back and look at the high-level architecture first. Have I used the right storage mode? Are we reducing network latency? Have we put all our components in the right places? Then start with the visual layer and work your way down. The visual layer is the easiest to attack because you can go and change reports very quickly without having to affect the underlying data models, right? So you can, and as we saw, it's possible to have too many visuals and visuals that aren't configured well, thousands of rows, too many measures in the tables. You might have to spend some time working with the business users and managing that change, of course. But that's the best place to start because you can make big impacts by not having to go to the lower levels. And especially in a larger organization where you might have external analysis services, or you might have specialist developers, BI developers, building your models and your calculations. It might be a bigger change and a slower change to actually change those underlying models. But I'm not saying you have to do one first and then the other. You could kick off both activities at the same time, but you want to start at the visual layer because you can get things done faster. Now, how do we measure performance? Well, you can't measure something and track its performance if you don't know where you started. So you need a baseline, right? And when I talk about roadmaps shortly, you'll see where we can help you with these baselines. Because right now, maybe I'll ask you at the end, how do people currently do performance measurement inside Power BI? I've seen all sorts of interesting techniques because we haven't given you the right tools, but that's coming. So build baselines in both Power BI Desktop and the service. Understand how the performance is going to differ from your development environment into your production environment. First, measure the effects of those report changes in Power BI Desktop. So if you're going to be changing visuals and doing drill throughs and things like that, now you have Performance Analyzer. You can see how much of a difference you're going to get before and after. An important thing is to use the same machine. Because the visual side of it is all client JavaScript, the slower your machine is, the slower it's going to be. We've seen some customers come back and say, hey, our very slow old machines are like twice as slow rendering this report. And we're like, well, unless you reduce the complexity of the report, we can't do too much here. These are very old machines. So I'm not saying use a super fast machine to do your testing, but make sure you use the same configuration so that you're not getting your client configuration, suggesting that you're getting a faster speed when it's actually the machine that's quicker and not your report that's quicker. Set reasonable performance targets. So I've seen really crazy things. CEO says every report's got to be 5 seconds or quicker. And it's a giant organization with so much data. Well, set those expectations up front. If you want this complex report with so many metrics from so many different parts of the model, it might be slower than the regular report because you've asked for a lot. Consider performance for percentiles of users. I think it's going to be impossible to have, unless it's a simple report, it's going to be very hard to have every single report perform under a certain threshold every single time. There might be times when, it's month end and you have thousands of people hitting it, or, there's some glitch in the matrix, like something can happen. So set a reasonable performance target. A suggestion, it could be something like P75. And by P75, I mean 75th percentile. So 75% of report executions will be less than 12 seconds. And there may be some exceptions, right, like those complex reports. I suggest that you build performance management into your solution lifecycle. So different problems can occur at each stage, from development to testing to production. So plan and test for scale before you go live. And there's some links there. So you can use Visual Studio web testing. There's a webinar out there, and we've had some partners take that webinar and scale it from a single machine running Visual Studio to Azure DevOps, where they're running hundreds of parallel tests at a time. So it's possible to do this with a little bit of work. And what you want to do is create that baseline per report and per model and monitor for regressions over time. If no one's changed this report, why is it slowing down? Is it that the usage has increased? Is it some other reason? Is our premium capacity now overloaded? It will help. And then knowledge sharing and performance awareness. It's unfair to have any single team deal with performance. So for self-service users, you might want to create a report template or something. This is a good idea anyway. Use a PBIT file with a theme and your company branding and that kind of stuff in there. But as part of that onboarding experience, you could teach self-service users basics like dimensional modeling, good use of relationships, optimizing the model by not putting everything in there. There's simple things that business users can do to make things quicker. Create a data loading guide. When we talk about Power BI governance, there's a lot of things you can do to actually onboard your users for a successful deployment. And one of the things that we overwhelmingly see big customers say is the pre-training that we built helped our deployment a lot. So part of this is, hey, just have some simple tips. This is not, level 400 training. This is just simple things. Avoid doing these type of things on big tables. Try not to do these kind of things in Power Query, and so on. The cool thing you can do also is now that Power BI Help is customizable, you can create your own documents, put them on your SharePoint or wherever you store stuff, and you can customize those help links in Power BI. So when people ask for help, they go to your custom content, not our content, and that's pretty handy. Enterprise BI, when moving from self-service to enterprise, I always recommend having both modes. You shouldn't do only self-service, you shouldn't only do enterprise. You need a governance process to migrate content from a self-service to a corporate mode if it's going to be used by broader groups. So that's all fine. Have a formal check process. Have the subject matter experts review those models for best practices and review those reports for best practices before they get published to everyone and the CEO, and then the performance sucks and then everyone's in trouble. I think the final point really is to approach performance tuning collaboratively. The fact that it covers so many layers from your architecture to your report design to your model design. In small organizations, sometimes it's one person who does all of that or a small team that does all of that. But in larger organizations, there could be actual barriers, political barriers, cultural barriers. So you need to approach it collaboratively and don't point the blame at any single layer. In all my work I've done, there's stuff that can be done at every layer. So it's nobody's fault. Nominate champions also, right? As part of your governance process, nominate either subject matter champions who know how to model data for that subject matter area, like finance or mining or whatever it is, drilling, whatever it is, but also have technical subject matter experts if possible. So you have like a double review before things go south. Okay, so key takeaways. Performance tuning can be complex. It can take time. There's no silver bullet. You might have to approach it multiple times, right? So my advice is to be systematic and data-driven, and I'll talk about roadmap soon, but use data to drive your decisions. Hey, we made these changes, and we got this sort of improvement. And when we looked at it in DAX Studio, which Marco is going to cover, or when we looked at it in Performance Analyzer, that DAX query looked like it was 30% faster, and track that over time. And there are often trade-offs to be made. Sometimes you might need to put extra stuff in the model, like aggregations require more space. If you're doing manual aggregations, you have multiple tables. You need to write smart measures that pick the context and stuff like that. So there might be extra overhead, there might be extra storage required, but it's going to give you performance, so you need to balance that out. Now, you can't tune indefinitely. You want to test these changes in desktop. You want to see what percentage improvement you might get in the reports and in the DAX. And look at where your ROI is going to be. If certain reports and models are being used by the most number of users, I'd suggest you actually start with those and then work your way down. But it just depends on the kind of benefit you might get. If you get a 5,000% increase in one of your heaviest used DAX calculations, that's a good candidate to do straight away. And just a reminder of features that can help with performance. The desktop performance analyzer, which I showed you, composite models and aggregations, which kind of go hand in hand. And there's tons more on the way. So I have 1 minute and 10 seconds left to quickly talk about the roadmap. Okay, so we're working right now on extending our not-so-great usage metrics to include performance metrics too. So the kind of numbers I've been telling you about, having percentiles and having trends, we plan to do that. In fact, we're working on it right now. If it all goes according to plan, in the next quarter, we should see that land. Desktop Performance Analyzer, we're thinking about little tweaks we can do to that. We just released the DQ functionality, the sorting functionality, and it's all based on feedback we're getting. So, go to ideas if you don't like stuff or if it's not working for you and chuck stuff in there. We do look at the ideas for them. Premium capacity metrics. So we get tons of questions around premium capacity metrics and understanding them and so on. There's a lot of stuff planned there. Better metrics, metrics in a way that show you what's happening in your system at the same time across different areas, so aligning the timescales on those metrics, We're looking at moving those metrics from an app into an embedded piece of content right in the admin portal. And we're looking at actually moving from giving you information to actually suggesting why things are not working and what you can do to fix it. So it's going to take some time, but that's what we're working on. Premium admin controls. So those are coming soon. There are going to be additional settings you're going to be able to tweak around memory usage per individual data set and also intermediate rows returned and things like that. CPU interleaving to share CPU more fairly when you have long-running queries. Things like this are coming very soon. The other thing that's really going to be important here is your detailed performance guidance, right? It's all great having functionality, but without the right guidance and documentation, that's not going to help. So right now we're working on restructuring the documentation and having specific performance articles on all the stuff I've been talking about, for all the common things people get wrong. Slices, report design, model design, et cetera, et cetera. And we're going to link to this from the product over time. So if we see a problem, we're going to be able to say, hey, you might want to consider doing X, Y, Z. Click the link, you go straight to the help article. And we're going to help you find the right people to talk to inside the organization. So if an admin sees a problem, they should be able to find out who the content owner is and contact them within Power BI so that they can collaborate and fix these performance problems together. And then there's much more planned. It's thereafter. We've got a long roadmap of stuff we're thinking about. So performance is actually a big thing, and we're considering it very, very seriously. So I'm bang on time, so I'll stop there. Time for questions. I have tons of resources and links, so please do download the decks. But yeah, thank you for attending, and hopefully you learned something and you can make your models really fast.